This video clip is part of EDUC5101G, a course entitled Learning with Technology, as offered in the online Master of Education and Digital Technologies program at the University of Ontario Institute of Technology in Oshawa, Ontario, Canada. This video clip is designed to outline the context or the situation in Module 4 within which problems pertaining to the epistemological order can be identified and or clarified. The material displayed in this video clip is presented by Dr. Roland van Oostveen, an Associate Professor in UOIT's Faculty of Education. The HCHI model, Desjardins 2001-2005, is being used in this course as it outlines the major technological competencies that will be explored throughout the course. This video clip will initially focus on the epistemological order, or the assigning of the lower order cognitive tasks to the computer software for processing, which in turn frees human beings to attend to higher order cognitive tasks in order to understand and solve complex problems. The epistemological order deals with issues and competencies revolving around the production of procedural knowledge, in that the user inputs data and commands into the technological object, which in turn processes the information according to set parameters and then finally displays the results to be read and interpreted. In order to use a spreadsheet, database, statistical package, qualitative data analysis system, concept mapping tool, or any other information processing software effectively and efficiently, the user must clearly understand the discipline involved as well as the structure, commands, and parameters of the software used. This conceptual knowledge is translated into operational methods or schema within the software as required for efficiently and effectively identifying and solving problems or for the accomplishment of specific tasks. Large quantities of numeric data are difficult to analyze and interpret when viewed in their raw form. However, when numeric data is entered into an electronic spreadsheet, such as Google Spreadsheet or Microsoft Excel, it can be manipulated using formulae and then subsequently graphing the results of the calculations that are carried out by the software. The graphical results are much easier to interpret in order to arrive at conclusions and evaluations of the situation. Depending upon the graphical results, the user may want to adjust the results by changing the formulae and then subsequently reinterpreting the changed results, allowing for predictions or what-ifs to be made. Epistemological objects or cognitive tools, Jonathan, 1996, are objects that are intended to engage and facilitate cognitive processing, or they can be thought of as a set of tools that learners need in order to serve cognitive apprenticeships, scaffolding the knowledge construction process. Kim and Reeves, 2007, state that cognitive tools are technologies that learners interact and think with in knowledge construction, designed to bring their expertise to the performance as part of the joint learning system. These tools then perform a specific set of tasks that set them apart from the great majority of software tools and web-based affordances such as those created by many online courses and instructional designers. Cognitive tools are then computer-based tools and learning environments that have been adapted or developed to function as intellectual partners with the learner in order to engage and facilitate critical thinking and higher order learning. And that's Jonathan, 1996, Computers in the Classroom, Mind Tools for Critical Thinking. Cognitive tools can benefit learners by serving the functions as follows. They support cognitive processes such as memory and metacognitive processes. They share the cognitive load by providing support for lower level cognitive skills so that resources are left over for higher order thinking skills on the part of the user, of course. And thirdly, they allow the learners to engage in cognitive activities that would be out of their reach otherwise. And fourthly, they allow learners to generate and test hypotheses in the context of problem solving. And that's Lejoie and Derry, 1993, Computers as Cognitive Tools. As we saw in the previous presentation, Web 2.0 objects can be hypothesized to exist at the intersection of the informational and social orders. In a similar exercise, if we were to conjecture about the characteristics of objects that would reside at the intersection of the social and epistemological orders, we might think about components of the semantic web, or Web 3.0. The semantic web has been defined by Berners-Lee, Hendler, and Lasilla, 2001, as a web of data that can be processed directly and indirectly by machines. We can think of the semantic web as a set of information components that can be readily interpreted by software machines so that they can perform more of the tedious work involved in finding, combining, and acting upon information that's found on the web. Functions of this type can be seen as performed by a variety of bots that have been inserted into the programming of sophisticated search engines. The bots search out and index metadata that have been embedded into a wide variety of objects such as web pages, pictures, maps, etc. Similar functionality can be seen when choosing objects on Amazon or Chapters websites, and the site indicates additional books, CDs, and DVDs that you might enjoy. One of the most recent implementations of this type of technology can be found in the targeted advertising that is showing up on sites such as Facebook. The advertising is targeted based on a wide range of data about your choices as collected by the Facebook system. This brings us to the end of this presentation.